as per ASTM distillation, because if you are preparing any related to the product related to petrol, diesel or biodiesel, so there are certain standard process, okay, which are reported to characterize this, means determination of flash point, fire point, separating that, and these methods have certain kinds of name, D86 as per ASTM standards. Then some other standards are also available. Okay, so this is a ASTM distillation apparatus. So what you can see here, this is the distillation flask. It is enclosed in a particular insulation so that to prevent the heat loss. Heater is provided, and that is going to provide the heat to maintain the required temperature. Then the top is nothing but the thermometer is inserted within this particular packed type of the column. It's not a packed column, it is open column. And here the condenser is attached to the one case where reflux is there. So whatever the distillate is there, that distillate is connected under the graduated cylinder. So here you can see that particular setup which is available. So this is nothing but the heater which is going to maintain the temperature within this. Then the fractions based on the difference in the boiling point of the fractions. Okay, so they are having with the low boiling point, they will be remain here, and those who are having the particular boiling point, they will get distilled. Okay, and then we are getting the more volatile component, especially in the graduated cylinder, which will be collected at this one. Now here there are different kinds of volumes of the flasks are available: 100 ml, 200 ml, 500 ml, 750 ml, 1250 mm across this one. But here we are considering the 100 ml of the sample in this figure. Okay, so the distillation rate occurs at the rate of 5 cubic centimeter cube per minute. The first drop may enter into the condensate within 5 to 10 minutes, but generally it occurs at its boiling point when the temperature is recorded at vapor temperature recorded as 10 cc per unit of the sample. So for every 10 cubic centimeter of the sample, here the vapor temperatures are going to be recorded, and here maximum separation up to 95% can be obtained across this. But here fluctuation may occur within this. So this is one kind of the drawback for ASTM distillation, but which is not in case of true boiling point apparatus, that is the batch distillation. Okay, and the dryness occurs at the bottom because we call it the fluid boiling point apparatus. Now in this particular case, the dryness is occur because of more quantity of the liquid is vaporized in the above surfaces. Okay, more quantity of the liquid is always vaporized. So that's why if the temperature is reached to the boiling point, then higher things are going to be higher separation of the liquid mixture can be possible. So this was about American standard, that is about what we call as ASTM distillations for that particular process. ASTM distillations. Okay, so this was particularly related to the ASTM distillations. So in this next things, what we are going to discuss is about the thermal properties of the petroleum fractions. Okay, now what are the various thermal properties for the petroleum fractions? So first thermal property is like a specific heat. Now everyone know specific heat, it is the amount of heat which is required to burn a particular fuel per unit mass. Okay, and specific heat is calculated in the form of Q is equal to mCp delta T. So here we consider only sensible heat is going to be transferred into that considerations for a particular petroleum fractions in the distillation case. So especially it lies with the temperature in the range in between 0.3 to 0.85, because the specific heat for water is considered 0.85, but it should be below that for petroleum products. So it lies in between 0.3 to 0.85. Okay, so it lies in between 0.3 to 0.85. So this specific gravity, especially lighter fractions have higher values, but it depends upon what is the temperature. Especially, I will say that what is its boiling point. Okay, it depends upon this API gravity of that particular fraction, because again it depends whether the fraction is under atmospheric base. Okay, whether the fraction is under particularly naphthenic base or it is the intermediate base. So this is the simplest formula to calculate that particular positions, that is specific heat is equal to 1 upon rho 0.424 plus 0.00081 into T. 0.00081 into T. So this is the simplest formula for that one. We have the numericals that we need to solve on that particular course. Okay, so that is based on this formula. So specifically, is my suggestion, you should note down this formula and you need to by heart this, because these are solved to solve the numericals. Okay, so rho is nothing but the specific gravity and T is the temperature in degrees Celsius. Okay, so this was the first property, what we call as specific heat. So it is the amount of heat required to raise the temperature of the substance either by means of 1 degree Celsius or 1 degree Kelvin per unit mass. So here we are considering only the specific heat which will be available for that consideration. So these are the simple things. You are already aware of this. Next is the heat of combustion. Okay, everyone, we know that heat of combustion, it is the amount of heat which is released when 1 kilogram of a particular substance has been undergoes combustion, means undergoes reaction with the oxygen. Okay, that we simply term as heat of combustion. Now here the hydrogen has almost distinct for heat of combustion. Okay, and here uh, the higher hydrogen hydrogen in the fraction has more amount of heat of conduction. Okay, it has more amount of heat of conduction, and this heat of conduction is going to play an important role for that consideration. So this important role consideration occurs when we are getting certain less values. Okay, when we are getting certain less values for that particular combustion. Okay, so higher H2 in fractions has more heat combustion. So always remember that heat of combustion decreases from paraffins to aromatics. Okay, paraffins to aromatic, I am saying. Okay, as the carbon range goes on increasing, but at the same time hydrogen fraction should have also be increasing, then it is possible that heat of combustion will be more for that. Hence from paraffins to aromatic, heat of combustion goes on decreasing, not increasing, it goes on decreasing. So the heating value, or what we can say that the heat of combustion, okay, for a particular petroleum fraction or for a particular crude oil is calculated using this empirical equation. That is, heating value is equal to 4.34 into 10 raised to 4 plus 93.2 into API minus 10. That will come in terms of kilojoule per kg across this. So this is a formula that has been utilized for that synthesis. So heating value is equal to 4.34 into 10 raised to 4 plus 93.2 into API minus 10. That is, it will come in terms of kilojoule per kg of that. Okay, it will come in terms of kilojoule per kg. Okay, so this is simple heat of combustion. See, equations for calculating the heat of combustion for other substances or non-petroleum substances, these are the different. Okay, these are some empirical equations where a lot of researchers have worked over this, they have identified and they have formulated that particular equation. Okay, this on this. Okay, so this was regarding the heat of combustion. Next is nothing but latent heat of vaporization. Okay, latent heat of vaporization is, we know, that is the amount of heat required to change the 1 mole of liquid to vaporize. Okay, to vapor. Latent heats, obviously there will be a phase change, so it is the amount of heat required to vaporize 1 mole of liquid to vertical phase. Okay, and always remember that the latent heat of vaporization depends morely on temperature and the pressure. Okay, depends morely on the temperature and the pressures. So when this depends upon with respect to temperature and pressure, it is related to the molecular weight, API, okay, that is American Petroleum Institute gravity, API gravity, and it has molar average boiling points for that particular calculation. Okay, so these molar balance heat average for that calculation has again most important consideration. Correct. Next is latent heat of fusion. Okay, latent heat of fusion is simple convergence of solid to liquid without change in temperature. Okay, so especially these are used whenever the consideration is with respect to distillate or the consideration is with respect to wax formation. So in that case, we are going to study with that situations what we call as wax formation. So it is approximately 50% of the latent heat of vaporization for that. Okay, so generally related to the thermal expansion, petrofractions also suffer loss in the density. So coefficient of